Hi, welcome everyone. So, welcome to our next OpenFoam video. Today we want to talk about constructing our actual first case of chtMultiRegionFoam. So, we want to start with something really simple. And what are we talking about? Let's use Paint. MS Paint is always nice. Okay, so the most simple case is we want. Okay, let's say, let me use this color. Okay, I want a sphere. Okay, a sphere in a fluid. A sphere in a fluid. Okay. Okay, so what is this? What is this case? Maybe you'll have some initial conditions. Okay, so this will be a hot sphere, maybe about 500 Kelvin, immersed into a fluid. Okay, into a fluid of maybe 300 Kelvin initial temperature, uniform field, right? So this is a 300 Kelvin temperature. And it's for simplicity's sake, we just say it's an adiabatic box, adiabatic closed box. Okay, it's an adiabatic closed box, and now we'll just have this sphere sit in this fluid and cool down. The fluid will be around the sphere, and then the hot sphere will heat up the fluid and it'll cause some natural convection currents, and we'll like to see what that natural convection current look like. Okay, so yeah, so I want to start by opening a FreeCAD, and it'll start our case. So this is a FreeCAD. It's the, what do you call that, computer aided design. I'm going to create something new. Okay, so I'm going to start by going to making a new part. Okay, and I just want a sphere. So the sphere will be okay, it will be 3 cm in diameter. But remember, OpenFoam kind of has this funny thing where whatever it is printing in meters, right? So the thing is that with FreeCAD, the files, the STL files that it outputs are always in a mm. But there's no unit, so there needs to be a factor of 1000 dividing by 1000. So when you see mm over here, it should be in it is the equivalent of having a 5 meter radius sphere in OpenFoam. So we want let's say a very small sphere, maybe 3 cm diameter, or 0.0, yeah, it's in microns. So you can change the unit to, okay, discard. So let's see, calculator, just don't mess this up. 1.5 cm. Use a 1.5 cm. So 1.5, okay, 1.5 here, divide by 100 is 0.015. So I should put in here, assuming I treat this as if it was a meters, 0.015. So 15 micron sphere, and okay. So now this sphere is supposedly 15 microns. So yeah, sorry. Anyway, just to double check, yeah, I just wanted a radius of 3 cm, which is 0.015 meters. So what I want to do is to change this to 0.015 meter radius. And here you'll see it changes to 15 micron. So 15 microns, that's the first thing. However, you don't see the sphere actually changing its size instantly. So what you need to do is just press the refresh button over here, and then you see the sphere suddenly shrink. How do you want to zoom in? You just use the mouse wheel to scroll, Control Shift and right click, pulling up to zoom in, and then Control and right click to shift it around, and that's where we get our sphere. Next thing we want to do is to export this sphere. So you want to export this sphere, and you just go to File, Export. I want to use an STL file. So the thing we want to use here is a STL mesh, which is right here. Then I want to put it on the desktop, and that is yeah, let's do small sphere or 3 cm sphere, OpenFoam. Right, so I can pretty much exit this because that's all I want to do in FreeCAD. Yep. Oopsie. So I'm on my desktop now, and I want to view this sphere. So what can I do to view this sphere? I can start using ParaView. So ParaView is going to take up some time to start up. I'll fast forward it. So ParaView has started up, and I just want to double check what is this STL file like. A simple sphere, no, 3 cm sphere, OpenFoam.stl. So this is what it looks like, and if you want to check the size, as always, we can take a look at the axis here. We can display axis on this sphere. So where are the axes? Sorry. You can you see this data axis grid. Click it OK, and you should be able to see. Alright. Yeah, you should be able to see it. So remember, OpenFoam likes to interpret all these numbers as meters. So this is 0.015 meters. Alright. Yeah, so this is while FreeCAD likes to interpret all these numbers as mm. So our STL file is pretty okay, no issue with that. I'll just minimize ParaView now, and I want to start to copy this into our case directory. So as of now, we don't have a case yet. So what template can we use? So I'm in the Heat Transfer YouTube chtMultiRegionFoam file. Again, going to upload all this to GitHub. So first thing first, I want to go to Foam Tutorials, and I want to navigate to, okay, let me check, clear this up. I want to navigate to this Heat Transfer, chtMultiRegionFoam, and let's look for Snappy Multi-Region Heater. So this is where I want to get a reference case. Okay, the Snappy Multi-Region Heater. Why do I select this case? Because it has the snappyHexMesh utility and everything already coded in. So modifying it from a Snappy Multi-Region Heater should take less effort than, say, starting from scratch like pimple foam, for example, or buoyant pimple foam. So I have this, and I'm going to copy all of this directory over, Control C, and I want to put it here, CPAR. I'm going to put this and put this file, and I'm going to paste it here. So paste it here in the file, what do we call it? Hot sphere in fluid, or you can put hot sphere in oil. So it's a 500 Kelvin, right? 500 Kelvin case 500 Kelvin sphere in some fluid. So let's go to the one we call hot sphere in oil. Alright, so there are a few files here. I want to remove this all run file, kind of redundant here. So that's it. And the first thing first, what I want to do is have an all run pre. So I'm gonna copy this all run serial. We don't want to do any parallel things just yet. We always try. Oops, sorry. We always want to try to do things simply first. So we do a serial case rather than a parallel case first. So all run pre serial pre. So that means yeah, it's just an all run serial pre. And in this file, all I want to do is get all the meshing and the boundary conditions set up. So let's go to all run serial pre. Okay. And what next we want to do is to, of course, change this sh to bash. It should be in insert mode. Write this to OpenFoam. Write this to Ubuntu. Why do I want to do this? Remember a few videos ago we found that all these brackets won't work in Ubuntu Windows subsystem for Linux if this thing isn't written properly as hashtag exclamation mark bin and bash. So that's the first thing we want to do. Now, like I said, want to make sure this is only an all run pre kind of a file to set up the mesh and the boundary condition. But for the first part, we want to focus on just setting up the mesh first. That means all I want to do is to just start running these 4 scripts. So BlockMesh, surface feature extract, snappyHexMesh, restore 0 directory, and run the application, split mesh regions. So everything else I do not want to run, therefore I put a £sign there. Okay, £sign here. And these things I kind of want to delete because there's nothing I actually want to do using these files. Okay, so I'll delete them first. Insert. Okay, delete. Okay. Yeah, so deleting everything's done. I want to write and quit, so :WQ, save and quit. Next thing I want to do is to get my STL file into this directory, into the constant directory. Right? I want to get it here into the tri-surface directory. So what I do is go to, on my right Ubuntu window, I clear up first, I go to Mount and C, on C, which is my C directory. I go to users and my own username, the users, and I go to here, my username, and I go to desktop. I clear up. Okay, and what I see here is I see the 3cm sphere OpenFoam STL file. What I do is copy the 3cm sphere OpenFoam STL, and I want to paste it into this directory. So I'm just going to copy this directory and I'm going to paste it here, and I'm going to put in the tri-surface file. Okay, and let's see whether it pops into our tri-surface directory. So looks like it is a success. It is over here, and I want to get rid of the old geom.stl. So remove geom.stl. So all right, so let's use the script to kind of give ourselves a guide. Okay. Oops, sorry. Let's use the script to give ourselves a guide as to what is the next step. I'll run serial. Oops, sorry. I'll run serial pre. First thing we want to do is BlockMesh, right? So what can we visualize in our paint? What are the dimensions? First thing first, I want a 1 meter cube. So a 1 meter cube, x, y, and z. So yeah, it's 1 meter. So let's make that using BlockMesh. So let's go to BlockMesh dict in system, BlockMesh dictionary. So the scale is 1. The vertices I want to have a 1 meter long, 1 meter cube. So I just changed all this to 0.5, and then I increase the x by 1 meter, so it becomes from negative 0.5 to positive 0.5. I do so on so forth for all the vertices. So I'm going to fast forward that part, don't want to bore you. So I just type everything out like that, and I'm going to okay, better insert, delete, and save it first. So remember, this is negative 0.5 x, y, and z. Increase the x, increase the y, subtract, increase the x, increase the y, and subtract the x. Yeah. So then you increase z, you increase z, increase x, increase y, minus x. So that's how things are usually done. Then you look at the blocks. We can take a look at the grading. Instead of 30 10 10, maybe we put the 30 30 30. We use a simple grading. So 30x, 30y, and 30z. Yeah, so 30x, 30y, and 30z. Then the edges are as per normal. We do not want to touch that. Whether it's patch or wall, to me doesn't really matter at this moment, but okay. I mean, in case there's turbulence, I think it's always good to use wall instead of patch. So that in case there's a turbulence, we can use those wall functions. I mean, it's easier that way. Patch is just so generic, but we want a closed wall, so we're gonna close everything off. So that's the BlockMesh. So BlockMesh is done. Next thing we want to do is I'll run 0 and pre. Let's take a look at surface feature extract. Surface feature extract is the dictionary should be found in system if I'm not wrong. We have surface feature extract dictionary. So they say it's geometry.stl extract from surface blah blah blah. So instead of geom.stl, we use the 3cm OpenFoam.stl here. So let's copy, and I'm going to insert and paste by right clicking, and that's all. So that means I'm extracting the surface feature from this, and that should do it. Alright. And what is next? Next thing I want to look at is all run 0 pre. Okay, next thing is snappyHexMesh override. So let's go to look at snappyHexMesh, the dictionary. Alright, so again we are at snappyHexMesh dictionary. Let's examine line by line to see what we want to do. The geometry here, instead of geom.stl, is the 3cm OpenFoam sphere.stl. So this is not the file I want to use, is this. So this is a 3cm OpenFoam sphere OpenFoam.stl. The name should be, I'll just call it sphere. So whenever I want to call on this object, I want to call on this STL file, I'll just call the sphere. Okay. So explicit feature H refinement. Okay. So the file should be not geometry feature HMesh. I think it should be the 3cm sphere now, because we were doing the surface feature extract dictionary and we changed it from geom to 3cm sphere. So I'm going to write it in. Okay, I'm not going to change any of these refinement parameters, so any of this not going to touch. This is what I'm looking for. Level 1 refinement, sure. So the refinement surface will change from geom to sphere. Alright, oopsie. Gonna undo that. Undo. Okay, so colon and U to undo. So what, 3cm OpenFoam. Okay, this shouldn't be, this should be sphere. So refinement surfaces, it will be the sphere only. And resolve sharp features angle, nothing. Refinement regions, we don't do anything. Now this thing is important, mesh selection. From this file we have copied over, we have the locations in mesh, and these are the locations. We have the heater, right solid, left solid. Okay, so we don't want any of this. We just want two regions called, one is called the sphere, one is called oil. So the heater, I'm going to get rid of it. I'll just put sphere, and the second one I'll just put oil. Now I'm going to delete all of this, save, and let's alter the coordinates. So remember, we are doing a very small sphere, so let's put it somewhere slightly off the center. Okay, and the oil, we want it to be close to the edge, so maybe 0.495 on each of these. So X, Y, and Z, 0.495. That should be the coordinates for the oil, because that's definitely outside the sphere. And remember, it's a 0.015 meters, 0.015. So this should be somewhere very close to the center and within the sphere. Alright, so yeah, 0.015 should be within the sphere, and let's say, for example, yeah, this is a 0.015 meter. So 0.005 or 0.0005 is smack in the center. That should be where the sphere is. Okay. Okay, so snap controls, blah blah blah. Don't do anything over here yet. Okay, so etc, etc, etc. Mesh quality dictionary. Okay, much tolerance there. Okay, so if I'm not wrong, so yeah, if I'm not wrong, I think the surface feature refinement should be, yeah, I think if it's a explicit feature refinement, then it should be this one. Okay, so I'm going to exit this, save and exit. Should be okay. Hopefully nothing should go wrong. Let's recap what we are doing here. So what I'm doing is just to run BlockMesh, surface feature extract. These are just to, the surface feature extract is to help the snappyHexMesh, what do you call that? Have a smooth surface for the sphere. And restore 0 directories to copy the 0 directory file over, and split mesh regions goes by cell zones according to the snappyHexMesh. So let's see, constant. Anything else I need to change for now? Of course, I'll be changing all these other regions. Oh yes, and I need to take a look at the region properties. Okay, so the fluid regions, I want to change it to oil. Okay, oil. And of course the solid region, I want to change it to sphere. Save and quit. Later I will want to change all of these, but for now let's try and run it first. And I'm going to leave out the change dictionary because that's not necessary yet. I'm not going to do change dictionary yet. Let's see whether there's anything else to change. Any other dictionaries I need to change. So BlockMesh, decompose parallel. Nothing else we really need to change. There's no other dictionary, so let's just run the thing. All run serial pre. All run serial pre. So that should run BlockMesh and everything. So I'm going to navigate on the right hand side to my original directory, cd github OpenFoam workspace and OpenFoam Heat Transfer YouTube and chtMultiRegionFoam and hot sphere and oil. That's where I want my stuff. Okay, let's take a look at the logs, see whether things are running correctly. So log snappyHexMesh, and it looks like we have an error. So foam fatal error, expected a bracket while reading the list, line 32. So let's take a look at line 32 in the snappyHexMesh dictionary. System, snappyHexMesh dictionary, line 32. Where is line 32? Okay, let's go to line 32. BI system, snappyHexMesh dictionary. I think my recording size kind of blocking. So okay, that's line 32. I should be able to see here. Line 32. Okay, so where's 32 is here. 3cm OpenFoam .stl. Hold on. Let's take a look on the right hand side. We log snappyHexMesh. Okay. Well, BlockMesh should be running correctly. Just want to check that first. Okay, BlockMesh is the last thing that should be problematic, so that's fine. Let's go to surface feature extract. Okay. Looks like there's a problem here. There's a problem here. So it says expected bracket while reading this on line 17. Okay. Okay, let's see. So there are two errors here. BI system, surface feature extract dictionary. So 3cm sphere OpenFoam STL. So this should be line 17. Okay, let me switch to the right hand side. Funny thing, funny bug. Okay, so this is where the problem is. 3cm sphere OpenFoam.stl. Yeah, so let's yeah, I'm just looking at this log, and let's try putting in whatever they recommend. Maybe a bracket will work. Insert For all you know, it might work. So all clean, clear, all run, serial pre. So obviously something's wrong again, because it shouldn't be running that fast. All clean. Let's try again. All run, serial pre. So vi surface feature extract, log.surface feature extract. Oh, on the word cm sphere.stl. Ah, okay. I think I know what's the problem. Okay, so when I put 3cm sphere.stl, it looks like OpenFoam might have thought it was 3 was supposed to be some kind of opener, so to speak. That means when I vi system surface feature extract, yeah, that means when I put this 3 here, OpenFoam may say, hey, why am I starting this name with a 3? Are you trying to declare some variable or something, or do something funny? So maybe that's not what I should do. Maybe I try this. Okay. Or let me get a different name altogether. So let me just use sphere OpenFoam STL. Maybe the number is kind of screwing, messing around with the actual what do you call that? The syntax of it. So let me clean everything up first, and let's go to constant and try surface, and let's rename as sphere OpenFoam.stl. So sphere OpenFoam.stl, that's fine. I think shouldn't have an issue now. Let's go to system surface feature extract dictionary. So sphere OpenFoam.stl, that's for sure. And let's go to snappyHexMesh dictionary. Instead of 3cm sphere, let's do sphere. So don't start your names with a number, maybe it will mess up a lot what is trying to be done. Okay, and this file should be sphere OpenFoam extended feature chtMesh. Okay, so let's try again. All clean is done, and let's do all run serial pre. So snappyHexMesh is taking longer than expected, so that's longer than what we had previously, so maybe that's a good thing. Let's take a look. Surface feature extract dictionary. Okay, so surface feature extract seems to work. Sure. So it's taking all the things there, and let's take a look at log.snappyHexMesh. Okay, so it looks like snappyHexMesh is working properly. Let's look for any errors. Okay, I'm gonna go down a little faster. Okay, okay, snappyHexMesh is finished in 2.75 seconds. Perfect. And let's see whether we get our mesh correctly. Clear, touch, sphere.foam, and let's look at parview. Instead of this, I'll delete this, and let's take a look at our flux time vary. Let's go to chtMultiRegionFoam, hot sphere and oil sphere.foam. And yeah, okay, we see a box here, so let's take a look at wireframe. Okay, we see a very tiny sphere here. Alright, very tiny sphere here. Meaning to say, yeah, looks like it works. Looks like it works. There's a sphere, there is this wire mesh thingy, which is good. Very good. If I take away the oil internal mesh, which is over here, the oil internal mesh, I'll get just that. Take out the internal mesh, I'll just have the sphere here. If then I take out the sphere mesh and then put the oil internal mesh, it should get both of them, because yeah, because the thing is that you need to have an oil shape with a cavity in the shape of a sphere in the center. Of course, this thing isn't actually very nicely meshed, because this ball is very funnily shaped. Okay, but it is a sphere. It's supposed to be a sphere. We can always make the mesh nicer later on, but at least, well, we have a mesh with two regions, which is one is the oil and one is the sphere. So at least our basic job is done. So key takeaways from this is, remember always to name your files properly, so that we don't have a mess up like what happened just now in this video. So we will see what we need to do next. Probably do the boundary conditions and the proper regions, and yeah, I'll see you guys next time. Thanks for watching.